All right, welcome to Chapter 2, Code in Action. This is probably the most important setup chapter that you need to get right. So we'll go through step by step, making sure that everything is properly installed before we get into subsequent chapters. So first thing to check is you are in the right folder, and then see if your Docker is running. So you can see the Docker is indeed running. Just good, just what we started. Next thing is to create a kind cluster. So let's see how we are actually going to do it. So you should have this configuration files in your README file. So before we get going on that, let me just talk about what kind is. So Kubernetes and Docker sort of gives us a real multi-node cluster setup on a laptop. So we will create one control plane and two workers with two port mappings so that we can reach the ingress from the host. So let's see if this one would work. It is creating, it's doing its thing, creating the nodes, writing the configuration, starting the control plane and all that. Okay, excellent. So you can see that it has been started. So it's up and running. Excellent. So now we will move on to the next part, which is to set up Pulumi. So Pulumi connects to the kind cluster we just created, right? So it fetches the kube config automatically and declares the namespaces, resource quotas, and limit ranges via those modules and the packages. So this makes that cluster setup reproducible all the time, and then it's sort of version controlled instead of having like ad hoc kubectl commands. So to do that, what we will do is that first we will first go and set up the Pulumi. So you're here, going into the Pulumi cluster. Then we'll start a virtual environment. That, and now let's actually get that going. So we'll have bin activate. Good, you can see that it's up and running. Now let's make sure that we actually run the requirements for it. This should be in the folder here. You should come in here to Pulumi cluster. You should be able to see the requirements there. So let's actually go ahead and run that. Let's see. Sorry, I missed the install here. Okay, it says that it is all good to go. Requirements are all good to go. Now let's actually go ahead and do a Pulumi stack init dev. It's initialized. Then let's see, do our Pulumi up. See what it's going to do. It created everything, or it started creating everything. You can see all the namespaces, the worker nodes, and all the resources are all up and running. Excellent. So now that we are good with that, next step in the process is to do a quick health check, right? So we want to make sure that the nodes are ready and expected namespaces were sort of provisioned by Pulumi. And we saw that in the screen, but we'll just check one more time. So we'll do a kubectl get nodes. Aha, you can see those nodes up and running. Let's also look at the namespaces. Kubectl get namespaces. Very good. The namespaces are all up and running too. Good. So now the next step is to install Flux. To install Flux, the reason for installing Flux is that the manifest contains the Flux custom resources, your platform services YAML. So these custom resources would be your Helm release, customization, all that. So, and these CRDs only exist after the Flux running. So let's go ahead and get the Flux running. Let me see which, okay, I'll go ahead and run it here. Do a Flux install, namespace, Flux system. Hopefully I got that right. This is, yeah, so it just goes ahead and builds the CRDs and it's sort of verifying the installation, making sure that it is working as expected. You can see what it's doing there. Yeah. it has finished the installation. Now that we have done that, we can just do a flux check. Yeah, just run all the tests, making sure that it's passed. So you can see all that information here. Okay, good. Now let's actually go and deploy your platform services. So uh, this manifest sort of creates the Istio, Cert Manager, Prometheus, OPA Gatekeeper, all of them as the Flux Helm releases, right? So we'll create this application namespace first because network policies targeted. Um, so to do that, we will go ahead and see where we are. Okay, I think we are in the right place here. So let's see if we can do kubectl, create namespace application. Yes, namespace application is created. Now let's apply. We'll do kubectl apply NSF platform services YAML. So is the reason why you see these messages here is that Flux needs like a couple of minutes to install all the Helm charts, right? So uh, one thing that we should do is that we can try and say Flux get Helm release. So you can see, yeah, what is running, what is in the system. You can also try and do just wait for a minute and do kubectl apply some platform services.yaml. Just make sure that these issues sort of go away. So usually it might require you to sort of not do that like right away. So if you put a sleep command there, it sort of gives it enough time to actually go out and generate the constraint CRDs and all that. So you're not really going to see those messages around, something that is not existing yet, kind of thing. You can now see that this is all getting fixed, and it is making sure that the things that were missing from the last time are getting created. Now you can see that there's still something that is not completely done. So we might want to do just one more time. Just do a sleep 10 maybe this time. Do a kubectl, apply. See if this one's going to clean up everything. So you can see that from last time around, there were like about 3, 4, 6 problems. So now it has gone. The next time around, it was only a couple of problems. Now you can see that everything has been fixed finally. See that? So that is how we would probably do it. The reason I showed you these errors were because this is something that you would encounter. So this is how you should probably go and fix that. Excellent. So now that we have done that, the next step is to configure your Istio service mesh. So we'll label the application namespace for the sidecar injection and apply mesh config. This would be like gateways, virtual services, destination rules that will sort of control that traffic routing. If the kubectl fails with the gatekeeper webhook timeout, you can delete the stale webhook to unblock yourself. Right now, so if that happens, you just delete that. So let's actually try and see if we can run this. We'll come back here and say label namespace application, right? That's what we did. Then we'll have Istio injection enabled and overwrite if needed. So let's see if we got the command right. Okay, let's see if this would go through. Internal error occurred, failing with check ignore label gatekeeper. So when you have this, what you can do is primarily come here and say how you can, first of all, delete those webhook configuration and create it again. So what we are doing now is doing a kubectl delete of validating webhook configuration for gatekeeper and redo this again. Now it's got that right. Let's make sure that this is good. Okay, now Let's check if Gatekeeper is running. Excellent. So you can see that now this sort of works. So you continue to find small issues like this as you're working through it. That's why you need to spend some time getting all this installation right. Okay, so where are we? So we have done that. We have now ready to actually provision a namespace. So what we want to do here is, let's see, the next step would be the namespaces. So let's see the next thing to do, which would be we did the Istio service mesh, creating the namespace. Okay, let's see if we can do this one. So what we are doing here is that we are using the namespace provisioner. So this one, you might want to take a look at this one, how the Kubernetes namespace provisioner works. And within there, we are providing certain kind of resource for like the team name is backend team, it's an environment, staging environment. And then we'll do 10 CPUs and 20 gig memory and 100 pods. So we will do that, see if that actually goes through. So it's all doing for app team one. If you have read chapter two, you will actually see where all these things work. So you can see that namespace for app team one is now provisioned successfully. It's time for us to do some infrastructure tests. So what we need trying to do is this BATS test would sort of verify the um, cluster health from outside. So where's the BATS test? So if we'll go in here, infrastructure.bats, tell you how this test is set up. So essentially, it sort of verifies the Kubernetes platform if it's properly configured and all components, the Flux, Istio, networking are all operational. This is so important because if you don't get this right, you will be tripped up further again and again. So let's make sure that this is done. So you can see we know the batch version. This is good. Let's do the actual test. Okay, so good. So it says that it has basically all the tests have passed here. So as you can see, uh, setting this up is not difficult, but there are certain gotchas here you need to be thinking about getting it right. So, and that's the whole purpose of this particular code in action. So thank you for watching.